Good morning, lovely 13s. Right, buddies, for today's lesson, as I said last time, we need to have a great big lesson on practicing with integrating factors. It is quite hard, it's quite unique, and it's unlike kind of anything that we've done before. So I think that it would be useful for me not to make a long video, but to do one more example with you and then send you on your way to practice, 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 and ask me any questions that you can. So essentially, my buddies, what we're doing with integrating factors one more time is when you look at a differential equation, for instance like this one, you're going to find that it's not possible to solve it by separation of variables because you've got y's all over the shop, x's and cosx's and sin x's in this one, and it's just kind of a big muddle. Now, you're not going to be able to actually isolate x or y on their own, thus we need to use this integrating factor method. So, here we go, my buddies. Let's see if you remember. First things first is this is the general form. You need to get them all into this general form that you can see up here. Dy dx, so the derivative, plus a function of x times by y equaling a separate function of x. Remembering that p and q are functions of x. They're not actually just constants. Now our integration factor, which we spent, our integrating factor, which we spent ages proving last time, is this bad boy here. So you know for sure the number that you're going to times by is e to the power of p dx. Cool beans? Or the integral of p dx. So let's do it, my buddies. So first step first in this one, and if you feel confident, pause and don't listen to me, okay? If you want, you can just try this one on your own too. And actually, that'd probably be a good shout. I think everyone should pause and try this one on your own, and then just check back in on me after you've had a little bit of a go. So I think you should pause now. Pause, go. Right, and if you're sticking with me, here's what we gotta do. First step first, it's not in the correct format. We need the dy dx bit to be on its own there. So here's what we're going to do. Divide both sides by cos x to start with. Cool? Because if you do that, you get dy dx plus, and sin x over cos x is tan x, so it's going to be plus 2 tan x times by y. I'm going to keep that popped in a bracket just so you know that it's not tan of xy, it is 2 tan of x times by y. And on this side here, dividing by cos x, you're going to get cos squared x. Cool beans. Once we got this step done, what's the next thing again? That's right, buddies, you need to get your integrating factor. So here we go. Let's get the integrating factor. Well, you know for sure, we usually call it f of x, and you know for sure that it's just going to be the integral. No, it's not. It's e to the, it's e to the power of the integral of p dx. Now remembering, my buddies, that p in this equation here is whatever's touching the y. So we've actually got this. We have 2 tan x. Okie doke, buddies. So this is going to be e to the integral of 2 tan x dx. Cool beans. Now, it doesn't actually, in this example, it doesn't actually give this to you. So if you actually know that tan integrates to ln of sec of x, that's amazing. I didn't know that you would know that. And it's not in your formula book, so I thought I'd give it to you as a given. So essentially, my buddies, here's what we're going to do. I'm going to pull the 2 out because it's not playing a role in the integration. It's just a constant number. And this is going to be tan x dx. Cool beans? And now the integral of tan x is actually ln of sec of x. Cool beans? So I don't know if you know that. You could prove that if you wanted to. I think you could prove it, but at the same time, though, yeah, let's just do it. Let's not bother proving it. It's easy to prove. You should prove it. Yeah, you should prove it. It's easy to prove. Okay, and here we go then. This is going to be e to the power of 2, and the integral of tan x, as we say, is ln of sec of x. So that's what we've got there. Okay, then using our log rules, we can pull the 2 up into a power. So this is going to be e to, so this is going to equal e to the power of ln of, and I'm going to go circle bracket now, of sec squared x. Okay, I dropped the modulus because for squaring something, it's going to become positive anyway. And now it's beautiful like this because if you check this out, it's e and ln are touching, which means we can bin them off altogether. The final answer to this as our integrating factor is just going to be sec squared x. So there is your integrating factor. Cool. What do we do next in the solve step, my buddies? Well, in the solve step, here's what you're going to do. You're going to start by multiplying both sides by the integrating factor. So here we go. We're going to get this. So using the purple, we're going to get sec squared x dy dx plus, and we're going to get here 2 sec squared x tan x y, and that's going to equal, and times this by sec squared 2, this is going to be cos squared x sec squared x. Cool beans? Happy with that? Cool! Now, the whole reason why we do this integrating factor malarkey is for the next step here, is this is actually guaranteed, this part here is guaranteed, my buddies, to be a perfect derivative, which means it is the derivative of a product, so it's a product rule kind of thingy. So here's what it's going to be. It always is just going to be this then. It's going to be d dx. So in other words, this is an answer. So going back to the question, it's just going to be d dx of the integrating factor, which I'm going to show in a step, the integrating factor just times by y. Now, that's part of the derivation that we did to start with. Now, on the right-hand side, my buddies, here's what we've got. If you've got cos squared here, it's just going to stay cos squared x, but sec squared, as you know, is 1 over cos squared x. Cool. So in our next line, in our next line, we're going to be left with this. It's going to be d dx, and then here we're going to be left with open bracket. F of x was, what was f of x again? Oh yeah, sec squared x y, and on this side equals 1. Cool! And that's actually tidied it up really nice, because since it's all like this now, it's going to be, yeah, it's going to be lush. Are you ready? So integrate both sides. It's going to be y sec squared x, so it just doesn't change. And on this side, it's just going to become, well, we're integrating with respect to x, so on this side, it is just going to be x. Now, integration constant is needed in this instance, so plus c. Cool. Well, guess what? You've essentially done it, my buddies. So you pumped. Divide both sides by sec squared x. Y equals x over sec squared x plus c over sec squared x. Boom. Now, we can tidy this, and we will, because sec squared, you know, is 1 over cos. So 1 over cos is just cos. So that means y equals x cos squared x plus c cos squared x, which means final answer, to make it nice and tidy, it's just going to be this. Factorize the cos squared out. It's going to be x plus c cos squared x, like a beast, and that is the final answer. General solution there, because it's got a plus c in it. I reckon that that's in its tidiest form as well. I would think that that would be how I would like to see it, so I'm going to go with that will be the final answer. And that's it for me teaching today, so hopefully the video is not too long. It looks like I'm at 8 minutes here, so that's good. Here's what I'm going to get you to do. It's page 198, question 9, and questions 1 through 9. Now, you started question 1 and 3 a little bit last time, but my goal for you is just that you really have your head around it. So do feel free to try some more bits and bobs of 1 and 3, which you started last time. But now I think that when you've practiced enough, which you have done because of last lesson and now, you are probably going to be able to tackle some of the yellow and red ones too, okay? I wouldn't necessarily suggest starting on those. Do make sure you've got your head around it, but then try to pop into some hard ones today as well. And that's it from me. So, yeah, that's it. See you next time. Bye, buddies!